All right, so you have just completed your quiz on finding areas and finding probabilities where you were given context and then you had to make a z-score and then you found the area above or below or between two values. All right. So the next step that we're going to have is what happens if we are not given that particular information and we need to solve for, say, like the context value. So if that's the case, then if we don't have x and we need to solve for it, then how can we do x minus the mean over the standard deviation if we don't have that x? Well, the answer is that you would most likely be given information about a percent or a percentile, and you can use that to find the z-score. So what I'm going to show you is another way besides x minus the mean over the standard deviation to find a z-score. And then from there, we can do lots of other things with it. Okay, so let's take a look. Our calculator is going to do that again. When we got an area, we used norm CDF. When we did percentage, when we did proportion of observations, when we did the probability, we did norm CDF. But now they might tell us the percent. For example, right here, find the z-score for the lowest 10% of data. Well, let's take a look at what that means. That's telling me that there's this place, and here is the lowest 10% of data. So this time I know what the percent is, and the question is, what is the z-score at that spot? So if you remember from the z-score song, the x minus the mean over the standard deviation 1, there was another part to it. And it would go inverse norm of the area below, inverse norm of the area below, inverse norm of the area below is the z at that spot. And so that's what we're going to end up doing. And so I'll pull that up here in a minute and let you hear that. But let's locate inverse norm, the function on your calculator. So in order to do that, we're going to go second and then vars, just like you were doing, or wherever it was, if you had a different calculator, wherever you had found norm CDF, it's pretty much right underneath it. So wherever you had found your norm CDF, then look underneath, it's inverse norm. Okay, so when we get the inverse norm, it's possible that you come up with this full menu right here. Okay, well, when it gives you this full menu, again, leave the mean at 0 and the standard deviation at 1. That's indicating a standard normal model where we're using z-scores. Okay, now the catch is, to make this work, you always have to put in the percentage as a decimal, which is why I've been having you always do the decimal and then the percent. Because in this case here, we have to write the percent as a decimal and put it right there. Furthermore, it has to be the area below a particular location. So on this problem where it says find the z-score for the highest 10%, no problem. That is 10% below. So there's my 0.10 is the area, and then you have 0 and 1. So that gives you the z-score, negative 1.28. And I pretty much knew that that's where that was going to be. Look at how I drew it. Here is a z-score of 0, the mean. Here is 1 standard deviation below, and here's 1.28 standard deviations below the mean. So the z-score for this one is negative 1.28. All right, let's take a look at the next one. Find the z-score for the highest 5% of data. So let's see where that's located. So I've got this right here, and this is my top 5%. Okay, but what is the important thing that I told you? Inverse norm of the area below, inverse norm of the area below, inverse norm of the area below is the z at that spot. So, excuse me, this 5% is not the area below. So I need to change this problem around to get the area below. So if 95% is above that location, then how much is below it? And of course, that's 100% minus 5%. So that is 95% below it. So what I would do if I was you is you have your highest 5%, I would then automatically rewrite it as 95% below. Okay, then now you can go compute. So here we go. We're going to come on up here to our inverse norm. Go to your second vars, your inverse norm. Inverse norm of the area below is the z at that spot, 0.95. Okay, and there it is. Okay, so that's 1.64. Remember, we always do z-scores to 2 decimal places. So before I write that 4 down, this 4 right here, before I put this 4 in the hundreds place down, I'm going to look behind it, and that's just a 4, so it doesn't go up. So it is not 1.65, it's 1.64. Okay, and it is positive because I see it is above the mean. So that makes sense. So that's a z-score of 1.64. So we're going to practice finding those. I have one more, and then I'm going to let you pause and let you try this, okay? And we'll see how you do. Okay, so for this next one, it says, I don't want to erase all of that. I just want to erase part of it. So for this next one, it says the middle 50%. Okay, wow. Okay, so that's a big deal. Let's see what the heck how we're going to do that. Middle 50%. Okay, so I'm going to kind of draw myself this box or shade or whatever where I think that middle 50% is. Okay, so here's the middle 50%. Well, what you will notice is this is a case where you will end up having 2 z-scores. The negative version, and then its symmetrical mirror image, which is going to be the positive version. Okay, so do you remember how to get your z-score? You have to do inverse norm of the area below. Well, first, we've got to figure out how much area is over here below this z-score right here. So let's think about that. If 50% is in the middle, then ask yourself how much is remaining in these 2 tails, the lower tail and the upper tail. If 50% is in the middle, then of course you know 25% is down here and 25% is up here. Okay, so to get this z-score right here, you know what, I pretty much usually always do the lower one. So I'm going to do this lower one first, and I'm going to do inverse norm of the area below, which has 25% below it. So here we go. Inverse norm of the area below, inverse norm of the area below, inverse norm of the area below is the z at that spot. So 0.25 below it, and voila, there we go, negative 0.67. So that gives us our z-score. Now, there are 2 z-scores for this problem because there are 2 bounds, the left side and the right side. So we know if we've got this one with 0.25 below it. Okay, let's examine the next one. How much is below this z-score here on the right-hand side if it has 25% above it. If it has 25% above it, how much does it have below it? 75%. So watch this, and let's see what you think about this number here. Second vars, inverse norm of the 75% below. Inverse norm of the area below. Inverse norm of the area below is the z, 0.67. Something seems familiar about that. Let's look. It is positive 0.67. Well, what did we say the lower one was? Negative 0.67. So, this normal model is symmetrical. So, however far you are away on the negative side, this one up top, I never recalculate. I always just know it's the same, but on the positive side. So, once I do the left of it, I know what the top is of it. It's the positive version. So, my two z-scores for number 3 are negative 0.67 and positive 0.67, because when you have a middle percent, you have bounds on both sides because you have area between. Remember, when you have between, you have two. Okay, so I'm going to pause this video right here and let you try these. And I may actually do this video a little bit differently because I want to be able to write equations better in solving on the next page. And so you may not be able to see me, but you'll still hear me, but I'll be able to write better. And then we'll combine these videos together so that you can see the math involved in all of that. Okay, so pause and practice those 3, and then we'll see how you did. All right, let's see how you did on your numbers 4, 5, and 6. So on number 4, we did the inverse norm of negative 0.15, and that gives us negative 1.04. Okay. And then on number 5, it says the highest 8%. Well, remember, you have to have the area below. So if 8% is above, then 92% is below. So that's what you inversed normed, and you got positive 1.41. Now, this one where it asks for the area in the middle, you're going to go ahead and you're going to, let's see, it says the middle 20%. Okay, so let's talk through this and see how we figure out what's in each one of the sides. So we go like this. I'm going to draw this section in the middle. That's probably pretty skinny. It's got 20% in the middle. So if 20% is in the middle, then how much is left together on the sides? Well, that's got to be a total of 80%. So if there's 80% on the sides, then that means I've got 40% on the left and 40% on the right. Therefore, I'm going to do my inverse norm of 0.40, and I get negative 0.25. And so then what did I tell you about this right-hand side? It will be the So it will be this positive version that we have right here at the top. So positive 0.25. Okay, positive 0.25. All right, so there is how you do your inverse norms. Now, there's a song right here that we may come back to whenever we kind of get to some problems that utilize this, where you might start getting a piece confused, but it takes a little context to get to that. All right, so then let's move on to the next part of this, where I'll start to be using a lot of more equation solving. So what happens now is we're going to start solving for all these pieces that are missing. We might be asked, what's the context value? Or we might be asked, hey, what is the mean? Or how varied is it? What is the standard deviation? And then they might tell us straight up what the z-score is, or they might give us a percent to find the z-score, just like we did a moment ago. But the key to this is once you have
3 out of the 4 variables, then you get to do good old algebra to solve for what is missing. All right, so we're going to have to brush up on all of our algebra skills. So that is why I'm doing this video a little differently, so that I can draw better and solve the equations with you better. So here we go. Let's do it. The Beanstalk Club of Texas is limited to women and men who are very tall. If women's heights have a mean of 63.6, okay, so I'm going to start filling in the things I know as I read them, okay? 63.6, okay, and a standard deviation of 2.5. All right, okay, there we go. Find the following cutoff heights, okay? So let me see what that means. I think, okay, so first of all, it says find the following, okay, this word kind of is like, what do you mean? But it does say find the following heights. So I know that that is a context value. So I think that I'm going to end up solving for what the x value is. So let's read and see. All right, question A. The Parker County chapter wants to take women who are taller than 1.75 standard deviations above the mean. Okay, so let's kind of draw a picture. Here is the mean, and a mean has a z-score or a standard deviation of 0 because it is the mean. Then we've got the 1.75. That's like right here. Well, because that is 1 and then 3/4 of 1. So what I need you to know and get from that is that when it says the number of standard deviations, remember that the z-score is the number of standard deviations. So if it says 1.75 above the mean, then that's a z-score of positive 1.75. So I'm going to go fill that in right here. And so then the question is, how tall do you have to be to join the Parker County? So yes, indeed, then what I can see is that this x, this context value, is what is unknown. And that's when I'm going to end up having to solve for. So here we go. Here's how we do this. Let's see, we're going to fill in things into our z equals, and so you need to write that z equals our x minus the mean over the standard deviation, x minus the mean over the standard deviation. Okay, so let's erase and fill in the things that we know. Okay, so here we go. So I know the z-score is 1.75. So I'm going to put 1.75 right there. Okay? Then I know that the mean is this right here. The mean is 63.6. So I'm going to fill that in, 63.6. Okay? And then I know that the standard deviation is 2.5. So I'm going to, in place of the standard deviation, I'm going to put 2.5. And so do you see that the thing that is left, that is not known, is this x value here? And so we are now ready to do algebra to get that x value. So let's see if you know how to do that. So the problem well, what do you not like about this setup? Usually we don't like this this bottom, this fraction. So that actually is the thing that we would undo first and we would get rid of first. So we're going to multiply both sides, because we got to keep that equation equal. We're going to multiply both sides by 2.5. Okay, these ones over here on the right hand side canceled out because you had 2.5 divided by 2.5 is 1. Well, see what that leaves on the right hand side is x minus 63.6. Well, that equals, over here on the left, if you multiply 2.5 times 1.75, you get 4.375. Okay, so now here comes the next step. I need to be solving for this x value. So I need to get rid of this minus 63.6, and it's subtracting. So I do the opposite of subtracting and I add that. So this cancels, and then I'm just going to add those together. So my final answer, x equals, what those two added together is 67.975, and those are inches. And so that is the answer. So that's how tall you have to be in the Parker County Chapter Beanstalk Club. Okay, so let's do that for the next one here. So let's take a look. The Tarrant County Chapter has different criteria. They want to take only the top 8% of women. So I don't know what this is here, but the top 8%. So you have to be this tall, where that blue line is, to be able to be in the top 8%. Okay, so we're going to figure that out. Okay, let's see what we got. So come over here to the left. What information do we know? Well, the mean and standard deviation are still the same. So we still have that 63.6 and that 2.5. Okay. And how tall do you have to be? That means I need to solve for x again. Okay. And now comes this thing. See, whereas before we were told 1.75 standard deviations. Okay? We were told, hey, look here, 1.75 standard deviations above the mean. But that's not what they tell me here. Now they're telling me, oh, top 8%. So I need to find the z-score at that spot. Find the z at that spot. Well, this is what we have just learned. If they give you a percent, then that's your ticket to be able to find a z-score. That's what's so important. That's what the new thing for today is. And so let me remind you of something. And so I'm going to pull this previous page up and show you this right here. Because through years of experience, here is a super common mistake. My students go, oh, 8%? Well, I know there's something about I need to do the lower part. Well, what's the lower part? 0.92. So my students, either they'll say, oh, the z-score is 0.92. Or they might say, oh, the z-score is 0.08. And then I love it when they do that, sort of, because I get to sing this song and yell it at them and say, the percent is not the z-score. So if they tell you 8%, that is not the z-score, nor is 92%. The percent is not the z. It's not the z. You use percent. Use the percent to get the z. Use area below as the percent. Percent is not the z. It's not the z. You use the percent to get the z. Use inverse norm to get the z. Percent is not the z. So having a percent is a good thing, but that percent in itself is not the z-score. You use the percent to get the z. And we just learned that a minute ago. So I'm going to write that here. We're going to use that and go, oh, the z is inverse norm of the area below is the z at that spot. Well, if 8%'s above, then how much is below? That's 92% below. So there we go, 0.92. And then I go get that value, and that inverse norm of the area below is a z-score of 1.41. Okay, so now there we have it. We have 3 out of 4 things. We have mu, sigma, and z. So put it in this z-score formula. Z equals x minus the mean over the standard deviation. So let me fill in the blanks. Here we go. Z is 1.41 equals, x is what I'm solving for. X minus the mean is 63.6 over the standard deviation of 2.5. So there you go. See, here is an equation that we now do algebra to solve. So what are we going to do? Get the 2.5 off the bottom. Multiply both sides by 2.5. Okay, and then I'm going to come over here and do that. 2.5 times 1 point. So this multiplied together. 2.5 times 1.41 is 3.525. And now I'm going to put what's on the right-hand side, x minus 63.6. Okay, so what is left to solve for x? Well, add this 63.6 over to the other side. And when you do that, the right cancels, and we have the answer of 67.125. That is the height that you have to be in the Tarrant County Beanstalk Club. You have to be a little taller in Parker to be in the Beanstalk Club than in Tarrant. Okay. All right, so this last one is going to be very similar. And so let's take a look at it. I need to erase a little bit that kind of ran over on there. Okay, scoot it up and let's see what we got. The Dallas County chapter wants to take women in the 88th percentile. Well, let me start by putting down what I know. I know that the mean is still the same. Women are still the same average height with the same variability, same 2.5. Okay, here we go. The Dallas County wants to take women who are in the 88th percentile. How tall do you have to be in the Beanstalk Club in Dallas County? Well, once again, how tall do you have to be? So your height is unknown, your x is unknown, but I see this thing called a percentile. Do you remember that percentile means? That's how much is below. So if you're in the 80th percentile, then you are taller than 88% is the area below. So does that mean I come on over here and I go, oh, la-ti-da, z is 0.88 because that said 88%. Holy moly. If you do that right there, then I'm going to get to sing at you or yell at you. I'm going to get to say, percent is not the z. It's not the z. You use percent. Use percent to get the z. Use area below as the percent. So that's our 88%. The percent is not the z. It's not the z. You use percent to get the z. Use inverse norm. So use inverse norm to get the z. Percent is not the z. Okay. So here we go. Let's finish it up. We then definitely don't want Miss McClellan yelling that song at us anymore. So we are going to do inverse norm of 0.88 to get the z. Use inverse norm of the area below is the z at that spot. And that number is 1.17. Okay. So there you go, guys. Now, let's fill it in. Z equals x minus the mean over the standard deviation. So now this is going to be our third time where we're doing the same solving process. Fill in 1.17 for z. X minus 63.6 for the mean, divided by 2.5 for the standard deviation. Okay, now get that 2.5 off the bottom. Multiply by 2.5 on both sides. Okay, multiply. 2.5 times 1.717 is 2.925. Working 925, and that equals x minus 63.6. And what's the final thing? Add this 63.6 over. And then there we go. And I'm going to add those together. Oh, you're even less restricted. They're going to be nicer and accept even shorter people into the Beanstalk Club in Dallas County. So that's interesting. Kind of makes me think backwards. I would think they would be a little bit more stingy with who they left in. Okay, so there gives you that. And that's the basics. So I have done 3 of these for you. So I'm going to stop this video because I then want you to move on to some of these other ones that are the same idea and practice them. So what I'll do is then I'll just split it and I'll have another video which will then go over this problem number 8 because that takes up that whole page, okay? And so I'll just split the video into little pieces so you can practice and then check yourself. All right, so try it and then watch the next video to see how you did. Good luck.